Okay, welcome to my video. My name is Faiz Fadhlurrohman from the University, majoring informatics engineering. In this moment, I will explain my paper conference entitled User Interface Design for Solar Panel Monitoring System on Android Smartphones using User-Centered Design Methods. First phase is the introduction. We use petroleum as the main fuel, but because of the limited fossil fuels, which will eventually run out when we use continuously, we have to look for new energy resources. Since 1970, the development of renewable energy, especially in the field of solar panels, has grown very rapidly due to its easy distribution and low maintenance without having to use fossil fuels. Solar cells provide a new way for humans to get electricity without burning fossil fuels such as petroleum, natural gas, coal, etc. Despite all of the progress that we are having in this era for solar cells technology, the use of solar cell system that is integrated with smartphone is not widely available. It will be very easy if the process of monitoring the use of solar panel system and the application of smart home technology is done with a computerized system. For example, by using an Android-based application that has an intuitive and easy to understand interface system. Create a user-friendly interface using a user-centered design. The user as the center of the design system development process is called the user-centered design philosophy. In this method, the user is at the level of design sophistication of all the graphical interface used along with contents monitoring. When interacting with the solar panel monitoring application on the Android smartphones, the user must get the same comfort by with his experience using other systems. Second phase, related works. Human and computer interaction. Human and computer interaction itself is a discipline that examines communication or interaction between users and systems. The goal is to produce a system that is easy to use, safe, effective, and efficient. The system referred to here is not just a system that exists on a computer, but also a system that is widely available and in everyday life, such as vehicles, household appliances, and so on. And then the user interface. User interface itself is a combination of graphical elements and a navigation system. Effective user interface make the user focus on objects and subjects that are seen to be better. Unlike desktop devices, user interaction with mobile devices must be designed so that the period of user action is shorter than on the desktop devices. Action must be simple and focused. User-centered design. User-centered design itself is designing an interface that focuses the user as the main role in determining system requirements. And user must feel satisfied when using the system, and the user involvement is really needed in the whole process from initial testing, evaluation, and the design itself. And the user interface has to meet usability goals, such as useful, effective, easy to learn, and memorable. Third phase is the proposed method. The first step is defining the scope. Users of this application are people who are already fluent and accustomed to using smartphones, either new users or old users who are returning to using a smartphone. The application function implemented in this prototype is the process of monitoring solar panels and setting the smart home toggles, which are used by the user that have a solar panel. And then after that, we have to analyze the problem. The problem we face in here is to make an application that is interesting, easy to understand, and easy to use by users, both in terms of the design and structure of the display application menu. And then after we analyze the problem, we have to design the user flow. The user flow itself is a list of processes that identifies what the users can do in a system. It represents the flow of a system from the beginning. As we can see right here, we have the login page, the dashboard page, reset password, smart home page, register page, and log. After we have the user flow, we have to plan the implementation. In this case, we have two main things. The first one is the low fidelity prototype, and then the last one is the high fidelity prototype. Low fidelity prototype itself is a form of representation of software that has not been able to interact with its users. And then the high fidelity prototype is a form of representation of software that can interact with its users. After we implement those plan, we have to go to testing. Testing itself, display testing is done by giving a questionnaire to users to get a quantitative data. A 5-star rating scale is used for the questionnaire. 1 represents very bad, while 5 represents very good. The questions asked are determined based on usability and user experience goals. After that, we will look for the maximum and minimum percentage value. In this case, the maximum of the percentage value is 75 as 100%, and the minimum of the percentage value is 15 or 20%. And the range of percentage category is for 85 to 100% classified as very good, 69 to 84 classified as good, 53 to 68 classified as enough, 37 to 52 classified as bad, and 20 to 36% classified as very bad. Next up is the implementation. In this case, the low fidelity prototype is created using Adobe XD. As we can see right here, we have the login page and the register page. On the left side, login page is the starting page when the user opens the application. And if the user already has an account, then the user can fill in the email and password fields provided, so they can enter the main menu or the dashboard page. But if the user doesn't have an account, the user can open the register page on the right side to create an account. The user fills in the desired email and password, then the user will be redirected to the login page to continue the login process. Next up is the forgot password page and dashboard page. If user forgot his account password, the user can directly access the forgot password page. Here, the user will enter the email address, then the system will send a link to the user's email to change the password, of course. On the right side, we have the dashboard page. After logging in, the user will enter the dashboard page where the user can see whether the solar panel is charging or the battery percentage and see how much electricity has been used. After that, we have the smart home page and the logout page. In the smart home page, user can also access to turn off and turn on the existing gadgets at home, which of course are already connected to the smart home system. And if the users want to use another account, the user can access the logout page. And this is the high fidelity prototype. This prototype itself is created using Android Studio. This is the implementation from the low fidelity prototype that we made earlier. And this is the implementation on the Android Studio. As we can see right here, we have the login page with its email and password fields, register page, and then the reset password, dashboard page, as we can see right here, charging status, battery percentage, and the usage of electricity. On the smart home page, we can see the toggle for all the gadgets that are connected in the system of smart home. And then if the user want to change account, the users can go to logout page. After we implement all the things that we made earlier, we have to test the system itself. The questionnaire has been done by 15 people. This questionnaire technique makes it easy for users to assess the system. And as you can see right here, the questionnaire results are shown in table 1. From the 8 parameters of usability goals and user experience, the average percentage stage is 84.95%. It means that the design of this system is pretty good. And then the last one is the conclusion and future work. Solar panel monitoring application is an Android-based application that can be used to monitor electricity usage in places that have installed solar panels. Monitor solar panel battery percentage, monitor the amount of electrical energy that has been stored, and toggle panel settings that have been integrated with the smart home system. the creation of an application with an intuitive display and easy to understand by all people. Suggestion that can be given for the development of this application system is to conduct system evaluation periodically to anticipate the addition of system requirement and to stabilize the application, because there are still many systems that have not been able to work optimally on several different devices. I think that's all from me. Thank you for watching. I'll see you around. Bye.